Let's talk about parallel and perpendicular lines. First off, what are they? Parallel lines are two or more lines that never cross. So they look something like this. They have the same exact steepness, and the distance between them is the same the entire path. A lot of times people use train tracks as a good example of parallel lines. You might also see a ladder here. But the important thing to know is that they never cross and that they have the same exact steepness. Perpendicular lines are two lines that meet at a 90-degree angle. Oftentimes you'll see a little symbol like this telling you that that makes a 90-degree angle, therefore the two lines are perpendicular. So in our first example, I'll call our top line L and the bottom one M. Something extremely useful about parallel lines is that they have the same exact steepness, or graphically refer to that as slope. So L and M have the same slope. In my perpendicular example, I'll call these maybe A and B, and A and B don't have the same slope because that would make them parallel, but they do have a special relationship. A and B have opposite reciprocal slopes. So, for example, if my first line has a slope of 2/3, then my second line would have first the opposite sign of that. So since this is a positive 2/3, my new slope would be negative, and it would be the reciprocal, meaning we flip over our original slope. So perpendicular lines have slopes that are first opposite, so we change the sign, and reciprocal, meaning we flip it over. Knowing how their slopes relate is extremely useful when we are looking at two linear equations. So here, if I want to know whether my lines are parallel or perpendicular, the only thing I need to do is find the slopes and then compare them. So I'll call the top line line number 1, and then the bottom line will be line number 2. To find the slope of each of these lines, all I'm going to do is rewrite them in slope-intercept form. Remember that slope-intercept form is the equation y equals mx plus b, where m is our slope and b is our y-intercept. So the first thing I'm going to do to compare the slopes is rewrite each of these in slope-intercept form. I start by moving my 3x in my first equation over to the right. And then I divide everything by 2 to isolate my y. My slope in this equation then, that coefficient on x, is -3/2. In my second equation, if I want y alone, now my y is on the right-hand side, so I'm going to go ahead and move everything over to the left. Divide everything by 6, and I will reduce. I can rewrite this with the y on the left just so it looks a little bit more familiar. Now that I have my equation in slope-intercept form, I can look at that coefficient on x to find the slope of this line, which is -2/3. So now that I've found the slope of each line, I compare them. Remember, parallel lines have the same slope. Well, these two slopes are not the same. They're very similar, but they're not the same. So my lines are not parallel. Perpendicular lines have slopes that are opposite reciprocals, meaning one's positive and one's negative, and they are reciprocals of one another. Well, these two slopes are reciprocals of one another. The first one is 3/2, and the second one is 2/3, but they're both negative. We need them to be opposite from one another, so one is positive and the other is negative. So since these lines fail both the tests for parallel and perpendicular lines, they are neither parallel nor perpendicular. And for this example, that is it. Thanks for watching, and I'll see you next time. Bye.